When you think about it, most days on the calendar just kind of blend together, right? But what if I told you that one seemingly random day, March 10th, is actually packed with some of the most incredible stories of genius, innovation, and pure human perseverance in the entire history of mathematics? So let's just start with a little puzzle. What on earth could a division sign, an electric light bulb, and a world map possibly have in common? I mean, they seem completely unrelated. It's a bit of a riddle, isn't it? Well, believe it or not, the answer is that one single day, March 10th. That's the invisible thread that ties all of these things together. It's this wild coincidence that opens up a much, much bigger story about the people behind the math. So here's what we're going to do. We're going to explore this remarkable date, starting with the foundational ideas these thinkers gave us. Then we'll see how their math literally shaped the real world. Here's some truly powerful stories of survival. And finally, we'll talk about the legacy they left behind. All right, first up, let's talk about the pioneers, the ones who laid the absolute groundwork for centuries of math to come. These are the people who gave us the very language we use to make sense of the universe. And our first story takes us way, way back to the 17th century. We're talking about a Swiss mathematician named Johann Rahn, born on, you guessed it, March 10th, 1622. Now, he might not be a household name, but I guarantee you use his work constantly. And here's why. That symbol right there, the division sign. It's so simple, right? But before Rahn, there was no single standard way to write divided by. In his 1659 book, he introduced this symbol, which he probably got from his tutor. And just like that, one elegant little symbol created a universal language for a fundamental part of math. It made everything easier for everyone forever. Okay, now let's leap forward about 250 years. On March 10th, 1872, Elizabeth Stephansen was born in Norway. And let me tell you, she was an absolute trailblazer, especially for a time when academia was almost completely a man's world. I mean, just look at this list of achievements. It's incredible. She was the very first Norwegian woman to earn a doctorate in science. And her research? Oh, just the ridiculously complex field of partial differential equations. On top of that, she taught at a boys' school and, get this, showed unbelievable courage during World War II, using her fluency in German to help prisoners under Nazi occupation. And this quote from her students back in 1889, it's just priceless. It gives you such a vivid picture of the world she was navigating. They noted that some people found a female teacher rather modern, while other students got so flustered seeing her during exams that they'd completely forget everything they knew. It's a funny but really telling snapshot of a pioneer just calmly breaking down barriers. So we've got the foundations. Now let's move on, because math isn't just abstract ideas on a page. It shapes the physical world all around us, from the maps we use to navigate to the very lights in our homes. Let me introduce you to Karl Mollweide. He was a German mathematician and astronomer who passed away on March 10th, 1825. His life's work tackled a huge problem that had been a headache for map makers for centuries. How in the world do you show a round Earth on a flat piece of paper without totally messing it up? His answer was the Mollweide projection. Now, you've probably all seen the classic Mercator map where Greenland looks gigantic, like as big as Africa. Yeah, that's not right. Mollweide's map fixes that. It's what's called an equal area projection. It means it keeps the relative sizes of continents accurate. So yeah, the shapes get a little distorted, but for the first time, you could look at a world map and get a true sense of scale. And it's so good it's still used in atlases today. Okay, now for that light bulb connection. This is Francis Upton, who died on March 10th, 1921. He was a brilliant physicist and mathematician who became the secret weapon, the indispensable right-hand man to one of history's most famous inventors, Thomas Edison. In fact, Edison had this affectionate nickname for him, Culture, because Upton was so formally educated and scholarly. And they were the perfect team. Edison was the visionary, right? The genius tinkerer with a million ideas. Upton was the mathematical powerhouse who could take those brilliant flashes of insight and turn them into rigorous formulas that actually worked. There's this famous story where Edison needed to find the volume of a weird pear-shaped light bulb. Edison, being Edison, just filled it with mercury and weighted it. Problem solved. Meanwhile, Upton had already started working out the complex calculus to calculate it precisely. That one little story just perfectly captures their incredible partnership. Now, we're going to turn to a part of our story that's a bit more somber, but honestly, it's also incredibly inspiring. For some of the mathematicians connected to March 10th, their work wasn't just some intellectual game. It was an act of survival in a world that was being torn apart. Just take a look at the incredible life of Juan Jorge Schäffer, born in Vienna on March 10th, 1930. I mean, his whole life was a journey of displacement. At just 8 years old, his Jewish family had to flee the Nazi takeover of Austria. They managed to find refuge in Uruguay, where he grew up and started his career in math. But political turmoil followed him, and in 1968, he was forced to move yet again, this time to the United States. His life is just an absolute testament to resilience. The Soviet regime also cast such a long shadow. There's Lazar Gluskin, born March 10th, 1922. He fled the German invasion, fought in the Red Army, and was so dedicated to his work that he finished his PhD research while living in a tiny student cubicle, using the staircase as his office. And then you have the tragic story of Karlis Zalts, born March 10th, 1885. After the Soviets occupied his home country of Latvia, his past academic work was deemed suspicious. He was labeled an unwelcome person and was professionally silenced for the rest of his life. So, as we start to wrap this up, what is the real legacy of March 10th? Well, it's a day that somehow manages to contain a whole world of contributions. It shows you the immense breadth and depth of what mathematics really is. And the amazing thing is, we've barely even scratched the surface. The list of brilliant minds connected to this one day just goes on and on. You've got Frank Smithies, who shaped a whole field in Britain, Evgeny Sletsky, who used math to understand economics, Yaroslav Lepetinsky, a giant in differential equations. The list is incredible. And this really shows you just how diverse their work was. We're not talking about just one little corner of math here. The contributions from this one day span everything, from the most abstract, pure mathematics, all the way to deeply practical applications in physics, statistics, and economics. It is a whole spectrum of human knowledge. So here's the big takeaway, the thing I really want you to remember. Looking at all these stories from March 10th, it becomes so clear that math is never just about cold, hard formulas. It is a profoundly human story. It's a story about creativity, about pioneers, about inventors changing the world, and about survivors who held on to their passion against unimaginable odds. And that kind of leaves us with one last thought, doesn't it? If one single, seemingly ordinary day on the calendar can hold this much history, this much achievement, this much resilience, just imagine what other incredible stories are out there, hiding in plain sight, just waiting for us to look a little closer.